So today we're going to break up the entire session in 3 different chapters. Chapter 1 is going to be very abstract. I'll probably give some examples. Maybe also use my creative liberty to kind of explain the point, what ROS is and everything. Chapter 2 will go on some of the specifics of operating system and where ROS, robot operating system, sits in this OS world, and who are the users, some other things. And in the last chapter we'll go on with some ROS specifics. So we'll try to understand some of the key terms used in ROS. Okay? So the very first obligatory thing, what is ROS? Okay? So that's definitely one of the ROS, but that's not what we are here for. I guess we're here for, this is what ChatGPT said. ROS is an open source framework that helps the researchers and developers build and reuse code between applications. I found so many definitions for ROS. Every definition has some key elements, but you just have to stick with sort of one of them. So it's an open framework. Typically, researchers and developers use who build their robotic application. The key selling point of ROS is reuse and recycle the code. So for example, if somebody has the code to execute something, it's open, it should be open, and you should be able to kind of download that code and reuse it. For instance, somebody made a mobile robot and has a platform, or let's say they use off-the-shelf Amazon or say smartphone parts to control the robot, to control the speed of the wheels, and they have the code available on the repository. You should be able to just use it. You shouldn't just reinvent the wheel. Other example could be, let's say you have a vision system that's tracking some red colored dot or something. So you should be able to just use it rather than rewriting the code. So my hope would be, towards the end of this session, you'll understand more about ROS. ROS is also called a middleware, so you have a software, you have a hardware, there's a middleware, which obviously sits somewhere in the middle, so to speak. So it's also a middleware. It's a global community for engineers and published through stuff, blah, blah, blah. Let's do a quick activity about a mobile robot. I'm sure you all have a drawing thing on your screen. So, meet my friend here. It's have you ever played with this? It's called Mario Kart, right? And obviously I can control this robot. So if I were to, I guess it's unhappy with that. I left the tool. If I'm controlling that robot using my switch, obviously it's controlling the speed of the car, the direction, and it's giving you feedback, which is the display itself. So if you were to draw, like in a block diagram representation, what are the things, how do you make this happen? Give it a stab for like a minute or two, and maybe discuss among your peers. And obviously there will be some sensors that you're getting data from. You're doing some processing. You have a joystick, so there should be something that reads the data from the joystick and then feeds that to some controller. So you want to do your own version of what that may look like. Like maybe on these are light bulbs, so to speak, on the page. You want to try it? You can see, maybe as a group, what do you think about how you draw this in block diagram communication? While I try to figure out. Look for like a minute or two.
think about using one sensor.
I guess that's sort of joystick, so to speak. It's receiving, it's pulling data from here, and it's feeding it. It's pulling data from buttons and joysticks. Controller, like the controller knows that. What does it mean? So this is sending sort of high level message forward, down, those kind of things. The controller is taking that high level components and then feeding that to the motor itself.
So you're considering the controller to be the one that's on forward or
We don't know, so most likely the controller is actually on the way.
I want to see this.
So there are different controllers. The controller that's responsible for it. That's Hey, did you have trouble finding a room? I see. Let's have a seat. We have just begun. The only feedback is the video. Video.
So, like there's some sensing
Well, technically there is something that when I bump it, it just but it sounds like a fan thing. But that's not. Anyway, so I guess the whole point is you were thinking about things such as you have a sensor or sensors, so to speak, and then you have some actuators. So in this case, the actuator is going to be the actual motors. We've got two motors, one for propelling it, and the other one is for the turning. What's really happening, in one way I can say, is there is a block that's leading the joystick buttons, and that's kind of creating a high-level command, which is go forward, go back, turn, those kind of things. That is sent to the controller. The controller, what it's doing, when it listens to go forward, it knows that which motors to activate and at what speed it needs to be activated. And so that's one-way communication, and then there's a feedback as well, which is there's a camera on board, it's feeding the data back to the, I guess, the joystick. So maybe you can draw a joystick somewhere here, but this kind of gives you some sense of what's happening in an abstract way in the liver. So can I say that the whole point is you are passing different data back and forth to different elements. So with that as a backdrop, let's keep going further. This is one of the examples that like the show we've been doing just this past summer. And what you are seeing here is we have one of the rover that's navigating on its own in a linear. It's very similar to how you drive, how you do a cruise control on a highway, where you set the speed. Assuming you don't have a full self-driving Tesla, you are still doing the steer control, right? So the linear speed is being set, and what the controller is doing is it's using the point cloud to figure out where the rows are. It's trying to detect within the row how far off I am from the center and where I am pointed at. Given these two information, what control needs to be sent to the rover to make sure it's at the center. Everything's happening in the ROS world, and the key benefit is the kind of sensors we are using. LiDAR, those are we call industry grade, and they all have a ROS, let's say, package, which means for us to extract the information, which is, let's say, a point cloud, is easier. Not only that, we have several teams who have been working on the rover, and the big challenge for us is if you have different teams, for example, Ryan's team, the one on the PhD, Ryan and Katie, they had no idea how the rover moves. Right? For example, they are only sending the high-level commands to the rover, go forward, left, right. But there is a separate team in our lab who's working on the low-level command where okay, now I have a command that go forward, back, turn, left, right. How do those commands get sent to the robot, get sent to the actual wheels itself? Which means the team could not be talking to each other, yet we can bring everything together because we know that ROS is kind of like a Lego, so to speak. They just, if you have built it, and if I know if you have built something that's ROS compatible, I can just put it on a system. In terms of analogy, I guess this is a good analogy that I tend to say. ROS is not a programming language, by the way. Many people have asked me. So one way to think of is, let's say that the Mario, he speaks, he's Italian, he speaks Italian. Yes. Lego, let's say it's an Danish company, right? Even though they both speak the same language, let's say Italian. Let's say Mario happens to learn Danish and speaks Danish. That's still not enough. Mario needs to know like the culture, so to speak, to actually integrate the building blocks, so to speak. And that culture is what ROS is in this analogy. Not the best analogy, but because it's Lego and ROS is kind of like Lego, if anybody has anything working on ROS, it's easy, it could be easily kind of merged into an existing system. And because everybody, or most of the people across the board, they're using ROS, that means it's easy for you to collaborate. That's easy. Anyway, there's a second example, and I like this example also as a good explanation. Let's say, we have Chris here. He wants to send a package to, I guess, Kira. Now, let's say, you live across, you live several time zones apart, let's just say. How do you send it? You could just go and hand deliver it, I guess. I guess you have a better option. Or you can answer the same question as well. UPS? UPS? I knew it. We coordinated beforehand, right? So you can send it to UPS, and UPS can deliver that. However, UPS is not acting alone. UPS still needs to use, let's say we're in the US, so the US infrastructure. And then obviously they charge you money, right? I guess? Yeah. That's very important. So yeah, using the financial system, the transport system, all those things. So UPS is allowing you to deliver the package, but it still is using the infrastructure. So in this analogy, the country is acting as an operating system. You need to have an operating system. And then on top of that, there's a service that's called UPS. That's how you deliver the package. Now, in this case, the programming language is kind of like whatever is written inside the package. That's the programming language. UPS is just a service. And then UPS offers you several tools on top of it. So you can track your mail, right, where it is. You also have the option of faster delivery, or depending on how much you want to pay for that. Then there's an ecosystem as well. So not only different time zones, let's say you want to send a package across the globe in a different country, you don't need to know about, or you don't even need to have the currency of that country to have the package delivered. UPS, as long as there is UPS operating in that country, they can coordinate and they can deliver the package. So UPS is acting as like a delivery vehicle. So the robot operating system is the UPS in this case. It takes, you give your package and they will deliver it to wherever you want. Turns out that UPS is not the only option. You could use other services, FedEx, you have several options. Similarly, ROS is not the only option you have. You also have other options that includes PLC, highly used in industries. I have never used these. I know they exist, but that's all I know. You can also use MATLAB sibling to design your controller. You could, hey, DIY your own thing. I'm very sure you have used Arduino to design your own controller. Right? So that's, I call DIY. You can do it yourself. But the issue with that is, let's say you build a small, I guess, robotic system, and everything in Python, or everything is in Arduino. How do you explain that to somebody else? You probably have to show the exact code and everything. What I call it's not highly recyclable. And so just be aware that ROS is not the only option. You still have different options, and every option has pros and cons. For example, PLC, it's widely adopted across the industries, and PLC has its own ecosystem, which means PLC engineers, as long as they know that a factory is running on a PLC, any engineer who knows PLC could work on any factory, so to speak, and just know what's going on. Yes.
So something like LabVIEW or which kind of enable PLCs?
Exactly. You could use LabVIEW. Yeah, there are several options. Yeah. Feel free to interrupt me in between so we can have more of a dynamic conversation. Alright, that's kind of some abstract examples about what ROS is. Any questions so far? Or, yes?
Can you use like some networking like to do the talking between them?
You could, yeah. So which means we probably have to define our own like IP socket and do that. Totally up to you. You can use that. In fact, should have mentioned this before. When I say ROS, whenever I'm saying today ROS, I'm essentially trying to say ros2, which obviously it's a successor of ros1. ros1 used to use the TCP/IP protocol to communicate. ros2 uses a different protocol, just a network. Yeah. All right. So now that you know analogy-wise what's the role of ROS, let's understand the basic components of an operating system. To be precise, let's say Linux operating system. So we all know Linux, they have different flavors. You use a distribution of Linux. So Ubuntu, what we call, is one of the distributions for Linux. So if you have a Linux that's like a kernel, on top of that, you have different operating systems, and you can pick and choose whichever one you want. Ubuntu is pretty common. They have a steady release cycle, so we know every 2 years they will have a long-term release, and they usually support for the next 5 years, which is important because if you are let's say designing, if your research work spans over a few years, the last thing you want is to have, oh, the support is gone, I can't even fix it, those kind of things. So among these, Ubuntu is a good bet, a best bet to try. There are many. Fedora and Debian they're also common. I think Raspberry Pi is based on Debian. They use the same kernel. What happened? I'm not going to go too deep. It's not too relevant. But just so that you know, let's say this is the Ubuntu operating system. You have the hardware, RAM, CPU, and other stuff. And on top of that, there's the kernel right here. The file system, and all these are, the user cannot directly interact with that. That's the whole point of the operating system. User, you interact here. The OS exposes some of the API commands that you can use. So applications are built on top of the API commands. So applications could be, let's say you have a mail application that allows you to connect to the internet, fetch the mail, those kind of things. You might have application like a calculator. You might have different applications, so they're all built on top of this API. Okay? That's how a general operating system especially Ubuntu looks like. Now the ROS is kind of sitting right there and directly interacts with the API or the operating system. And ROS has its own set of tools. So if you recall from the previous example of the UPS, they have different tools such as you can track, you can, you can track the mails and you have, let's say, different categories or different tier options. So those are what we call tools specifically for ROS. Okay? So just be aware that this is where ROS sits in an operating system world. Now, what is there within the ROS framework or the ROS, I would say, middleware? There's something called EDS, which is I think by Microsoft, which stands for Data Distribution Services. And this is an upgrade from the last time because previously ROS1 used to use the TCP. So it used to use the internet protocol within the network or within the host machine to talk to each other. But we all know that the internet, every data they're sent as a package. Right? And the packages can get lost, which is not a good thing when you're having a self-driving car and one of the sensors says, hey, there's a pedestrian, you've got to stop there. You don't want that packet to miss, right? So, ros2, it changed that to EDS. Somehow, I don't know how it works, but EDS is an industry standard where the packages are guaranteed not to be lost. I don't know how it works, but it works. Yeah, question? On top of this distribution service, there's something called ros2 libraries. And on top of that, there are C++, Python, you name it, Node.js, any programming language. They support all the widely used programming languages. They have these code libraries. And then, this is where you as a user, you write programs here. For example, your program could be, let's say you like Python, so you might write a program to read the sensor or read the joystick buttons. So you use that, and then it will all be distributed among the system, all the network system. So all the code that you'll be writing sits on top here. On top of that, they have visualization tools. For you to, let's say you happen to have a temperature sensor, or it's an overkill. So you're reading the temperature sensor in ROS world. And then one tool could be like a plot. So when you fire up the tool, it would plot real time. Typical things as you expect from any development dev tool. What else? So currently the ROS version we are using, they're Foxy and Humble. Jazzy just came very recently. I don't know why, but they named their releases based on the turtle. And I had no idea that all these are names of the turtle somehow. Weird, I don't know. Like Androids, they have ice creams, right? So,
It's some kind of
some dessert, my bad. Yes, they use some dessert to name it. So ROS2 they use a turtle as naming scheme. And if you think about it, I'm actually skipping the odd ones. So, for example, Foxy, it came in 2020. The Humble is 2022. And Jazzy, which is released, I guess, in April of 2024. They're something that I call even releases. The odd releases are, I would say, temporary release. It's only as an experimental features. Okay. They usually support for, I don't really check back here, but they usually support for 5 years. Okay. And that actually aligns with the Ubuntu software, the Ubuntu releases. So if you don't know about Ubuntu, think you folks had installed Ubuntu 22, right? So 22 means it came in 2022. That's what I found it fairly recently. And all these even releases, they are called long-term support (LTS), and they are supported for next 5 years. So you are assured, rest assured that they will be supported for next 5 years. Yes.
So when you say like supported, like what exactly does that like entail? Is it like just supporting higher operating systems?
So managing the OS itself, like security updates and patches.
Oh, okay.
those
So
kinds
it's like Windows.
like Windows.
Okay.
Yeah. So yeah, that's support. These could also be installed on Windows. ros1, it was strictly available for Ubuntu, but ros2, it also supports Windows 10. Folks have tried on Windows 11, but that's unofficial support, which means if you as a user wants to use ROS, you are pretty much, you only have these two options. And my preferred option, my preferred choice is go for Ubuntu, which means if you're trying to install Proxy on Ubuntu 22, it's not going to be happy. So you've got to make sure you install the correct version for that. What hardware? These are some of the hardware that you can use to install. The classic vanilla option is you literally use a PC or some Intel Mac or something, and you literally install Ubuntu version and call it a day. Or you could use Raspberry Pi. 3 and 4 I checked, they all support Ubuntu 20, 22, and 24. Which means as long as you have Ubuntu installed on Raspberry Pi, you can install versions. The rovers that we extensively work on, we use something called NVIDIA Jetson dev kits. They are what I call more an industrial grade version of Raspberry Pi. They're a little pricey, but obviously because it's from NVIDIA, we can do a lot of real-time processing in the onboard. Now the funny thing is the Jetson family of the dev kits, they don't tend to go for the latest one. And I was reading some forums and they mentioned that they don't want to go on the latest one because the latest one is keep on evolving, which means they have to kind of do a catch-up work to patch everything in their latest version. So they are, in fact, they moved from 20 in 2023. So up until April, this was only supported right here. After this clock moved over to March of 2023, that's when they started supporting this one. And I have a good chance that up until 27, it's not going to change. So Jetsons that we use in the lab, they will be stuck with Humble till 2027. And as 2027 April rolls in, then they will probably release a new hardware and go to the other one. In a way, I think it's a good thing that they want things that's once deployed, they're much more robust and they keep on working. Yeah, that's just my conspiracy. Any questions on that? Okay. Now, the last part is we'll go deep into we'll learn some ROS specific terminology. Now, 3 things I want you to remember for now. In ROS, we have something called messages, topic, and interaction. Okay. And we're going to define all 3 what that means. So let's say, on a radio, you have a Baby Shark song that's being beamed on 92.4 FM. Anybody can buy a radio and tune to that frequency, and you can listen to the song. Okay. So in this case, help me identify the message. What could be the message? The song. Topic might be, okay, Everyone wants to get what's topic?
The frequency.
Exactly, let's see. So the topic here is a frequency, which is identified as, it's also like a channel, right? You can think of it as like a pipeline. And then interaction is a little complex. So the interaction in ROS is classified under three broad categories. And I know it's confusing. One is called the messages. It's kind of like publisher-subscriber model or upsell model. So one of them is messages. The other one is services and actions. What I call this FM radio station thing, it comes under messages. What that means is a broadcaster or publisher that's publishing the song. It has no idea how many people are listening. In fact, it doesn't care how many people are listening. Anybody with a radio, if you are in the range, you tune into that frequency, you will receive the song. This model is called publisher subscriber. In fact, if I go back to the sending a package analogy, you know those $20 off pizza, come here, my shop, promotions, emails, or what I call those are the publisher subscriber. I don't think they really care if the recipient has received it, they just send it out. This scheme is called publisher subscriber. There are two more, services and actions. So we will now understand what those models mean. Okay? So the first one, messages. So messages, you got a node somewhere. The node is sending some information. So it could be you have a temperature sensor somewhere, and that node is the temperature sensor. It's reading the temperature sensor data and sending it on a topic. So topic, again, think of it as like a unique identifier name that you need to send on. And then you have a subscriber that's receiving information. So obviously, these are, you can send from node to node. You can set at what rate I want to send it. If you want to send every 1 second or every like a minute, you have an option to set. We will dig deep into what the message type means, but just hang on to me. It's one-to-many and it's asynchronous. It could be synchronous or asynchronous. It depends on how you want to write that. So the messages could be point-to-point or one-to-many. So for example, one could, if let's say there are multiple subscribers, they will receive the same information. There could be multiple publishers on the same topic. So I don't know if you have ever, like back in Stone Age, when you're driving, using FM radio, and at some point the two different zones, they cross over the same frequency, so you tend to listen. And
Still happens.
It still happens.
Just across the like some shape borders.
Yeah.
If you hear two frequencies collide,
I think unlike the regular radio, it still happens.
Still happens.
Especially if you're like going on hills, going down.
So I'm not alone here, right? Thank God. So that's this strategy of passing information back and forth is called the messages. Confusing, but sure. And in the example we were talking about, there could be one publisher that's, let's say, taking the joystick data, it could be sending controller, what have you. Any questions? Okay. The other one is called services. So services are a little complicated than messages. It needs a response. So in the analogy of sending a package, I don't know if you know, sometimes you have an option of counterfoil where once it's received, they tear it off and give it back to the mail person, and then that person will deliver it back to you, which means it's acknowledged that it's been received. So the services are something you send a request and you wait for a confirmation before executing your next task. So where this could be useful, let's say you want to design a robot that exits a door, and the door is actuated, so it needs to open and then you exit. I don't think you can just bam the door and just go over. And it just so happens that your door takes, let's say, 10 seconds to open. So you want to wait for the door to open. So what one strategy, when you have a robot that reaches the door, it sends a command to the door actually to open. And let's say that one is responsible for opening the door. And there's probably a sensor that actually in real time measures the angle of the door, and you want the angle to go to, I don't know, like 90 degrees. So you send the request, hey, open the door, and you keep on opening. Once it's done, it's going to respond back. Done. Sweet and simple. And then you go on to the next step of going through the door. So this is called like the services, or in other words, service call. You're making a service call for things to happen. So, and this model is more of a very simple. You send something and it will acknowledge yes, no, those kind of things. In a big robot, we have brakes. So before moving, we have to disengage the brake. And there are actually sensors that measure whether the brakes has been disengaged or not. So we make sure that the brakes are disengaged before. So does this model make sense? It also keeps a track of if there's a drop-in connection, which means, let's say the link is broken, it doesn't respond, that means it's not going to proceed. So on comparing this with the previous model, the previous one doesn't care if anybody's listening or if there is a drop in connection, doesn't care. This one, very important. Third, that's called actions. Actions are, think of services taken to the services on a steroids, so to speak. Action, they're a little complicated. In fact, complicated to a point where even in our lab we don't use services because services are. What's the person who's orchestra or something? Yeah, what's the conductor? So services are kind of like a conductor. There are several nodes. They all are singing their own thing, but the conductor is kind of coordinating everything that's happening. So, as an example, let's say you want to build a robot, or rather a delivery robot that delivers. I'm sure he was keeping telling about buying a car to shuttle back and forth between the garage and here. But anyway, if this dream hypothetically ever come true, and we were to design something like a golf cart that would autonomously go to the garage, deliver something, and come back. So, if we were to use the action model, then the action would be we have a waypoint, right? So the action would be you send the waypoint to the autonomous vehicle. Now it's autonomous vehicle's job to actually execute or go to that waypoint. And this is kind of a longer task. You don't know how many obstacles you're going to avoid. If there are prospective students and a large crowd, it's probably going to wait for like 5-10 minutes and it will keep on going. So while it's executing that task, it's also sending a real-time feedback. It's real-time positioning, like EPA, so to speak, or the battery voltage, those kind of things it's sending. So it's much more elaborate task that is executed. And then once it's done, it's going to reply back as done. But compared to the actions, where it only responds yes, no, those kind of acknowledgement, this one is not just yes or no, it's also responding. Here I am, this is my current speed, those kind of parameters. So, messages, actions, and services. Somewhat clear. I think for tomorrow, I don't think we'll be diving into the actions and services. We'll be only doing the simple one, which is the messages. You send it, receive it. So, if you're nervous, just, it's a future problem. Okay? In summary, the messages are good for, it's very simple, good for most of the sensors, it's very easy. If you look at the code structure, you'll be happy. It's simple, 2 lines. The weakness, the messages gets dropped, you have information, and you can easily overload with so many topics and other things. It's kind of like when you're writing a program, I'm sure you must have encountered, you tend to write functions. But there's no rule that you don't need to have this function, right? You use functions to make your life easy, I guess. Same thing. If you keep on populating the PubSub model, probably will get complicated. So it's a decision you have to make. Services, it acknowledges that there's a missed call in terms of drop in connection, those kind of things. The weakness, it generally blocks until completion, but in ros2, they changed this to a synchronous and asynchronous model. So they support both, which means in ros2, if for some reason one of the nodes that drops connection, it doesn't crash the whole system. So you have to be careful where how the error handling is going to happen in the back end. Okay, so message types. Remember, we have only talked about how the messages are being sent over the call, right? We didn't talk about what kind of messages are actually in that message. It could be, when it comes to a temperature sense, a temperature data, it could be just the flow. You know, some floating variable, that's some data. So in ROS, these are categorized under something called standard messages, sensor messages, geometry messages. You can have custom messages. That's also true. Now, why do you want to use? I mean, you could use integer for everything. For example, let's say you have a temperature sensor, you have a range sensor, you have a GPS. You can read the latitude, longitude, and everything, funnel everything in float there. But the issue is, it will be harder for folks to understand if you're trying to collaborate, which means ROS, what they have done is they have created special containers for special kinds of messages. And the commonly used ones, for example, in the sensor message, let's say you're a robot, you have a GPS. It would make more sense if you use their own data type, which means somebody across the globe is trying to debug. They literally, they look at the code, they see that, oh, that's a GPS data type, so I know how to unpack it, how to kind of proceed with that. Just good organization skills, so to speak. So whenever you are sending a data, you also need to define what data type, what type of data it should be at the very beginning. So the standard ones are in float strings that everybody is aware of. You'll probably see tomorrow that you also have options to use GPS or IMU. Not only that, they all comes with something called header, and where you can, let's say there are multiple GPSs on a big system. So you can define GPS location 1 or front, back, those kind of things. They have pose and coordinates. These are very helpful for the manipulators that we have, where you need to have an X, Y, Z coordinate. So you can leverage those. You can define your own. I think stop you to do that. Okay. I guess that's all about the key terminologies that I wanted you to understand. This is probably for tomorrow, where when we create a ROS, we create in a folder or directory, we create a ROS workspace. In the ROS workspace, you have different packages. Package 1, package 2, there could be more packages. So for instance, the remote call that I showed you, one of the packages could be reading the joystick data. Other package could be, its sole job would be to control the motors. So there could be nodes which are speed control for the motors, those kind of things. And then you can have multiple packages within the workspace. So you'll see this structure probably tomorrow. Going really quick on, is ROS for you? Well, ROS is not kind of a one solution fits all. You really have to debate whether you need to use ROS or not. The biggest cons are it has a lot of overhead, it's highly inefficient, but it's good in terms of collaboration. And then, if I were to categorize the ROS users in 4 different categories, although you can argue that R&D is a university or industry, yeah, they're kind of all over the places. And the hobbyist, for example, if you're doing something at home, you're generally price sensitive, you don't want to spend a lot of money, which means using ROS, you have to really think about it. You want to use ROS. Because then you need to have a larger or powerful hardware control at the end. Universities, they tend to use quite a bit actually, especially depending on the lab. ROS is fairly common. R&D, yes and no. Industries, guess what? They try not to use ROS. For example, this example I showed you with the card. Compared to dollar, they're not using ROS because they're very price sensitive. I bought it for what? $90. I'm pretty sure the company would have made it $30, $40, I guess. And in that hardware, and whatever you get for the $30, $40, I don't think you can squeeze in a camera, a battery, everything. So what they do is, the company, they do all their R&D, maybe in ROS world, but once they know this is what the final hardware should look like, they usually make their own ASICs, which is an application-specific integrated circuit. And also, they don't want you to think around, so they kind of close everything down. And, so industries, they try to stay away from ROS. That's the key point. Some fun facts. I see graphs going up. But this is the adoption level. So you'll see the ROS adoption is kind of growing year over year. This is the global market share. I think Asia is currently the biggest market, obviously, with the increase in automation. So it seems to be growing. I guess NASA, they have the lunar mission coming up. That's also going to use ros2. Most likely it's publicity is coming to motivate ROS. Anyway, so key takeaway, ROS is a plumbing. It lets you deliver data from one node to another. It's an ecosystem. It has capabilities. Capabilities means if you want to design a motion, like from one place to another, you can leverage their own tool to actually do the motion commands. And there are tools. So for example, tools could be plot the real-time data or maybe record the data. And there are several tools available for it. I guess this probably is my last slide. It's a plumbing service. Remember the messages and topic. This will be helpful tomorrow. And tomorrow we'll actually try to create our own workspace. We'll create our own package and we'll create it our own. That's the goal for tomorrow. With that, I think that's